Hey everybody, welcome to week 34 asynchronous block day 2 work, activity 2.2, using additive inverses to combine linear systems. So like we were doing previously, we're going to be combining equations to get rid of one of the variables. So we're going to go from two variables to one variable, because it's a lot easier to solve for one variable as opposed to two variables. In the system of equations from the previous activity, one of the variables in both equations have coefficients that are additive inverses. What if a system doesn't have variables that are additive inverses? Let's use the strategy of linear combinations to solve other systems. So basically, they had this. And then we had 5x plus y is equal to 5. And then when we combine them, negative y plus y would be 0. And so we could add these two. And so we'd eventually figure out what is x. But in the meantime, when we add these two equations together, y goes away. So now what if we can't add them together like that? Well, we can trick it. We could switch it up by modifying the equations. All right. So remember, so that's what we just talked about. Negative y plus y equals 0. 5 minus 5 is equal to 0. Two numbers with a sum of 0 are called additive inverses. Let's give an example. Negative 4 and 4. What about 5? 5 and negative 5. What about 3x? 3x and negative 3x. All right, let's go back. So consider the system of equations. We have 7x plus 2y is equal to 24, and we have 4x plus y is equal to 15. So what they're going to do is they're going to change the bottom one of these so that it has a negative 2y right here. So we're going to multiply the second equation by a constant that results in coefficients that are additive inverses for one of the variables. Okay, well, see this 2y? We can get rid of that 2y by having negative 2y. How do we, what times y equals negative 2y? Well, it's a negative 2. So if they multiply these out, we get negative 8x minus 2y is equal to negative 30. And lo and behold, hey look, these are additive inverses. If you add those two together, you'll have a sum of 0. And so now we get x by itself. And now we can solve for it. What is x? Well, x equals 6. After we solve and figure out what one of the variables is, we substitute that value back into an equation and solve for the missing variable. In this case, we're solving for y. So we multiply. So the steps, we multiply to get additive inverse, and then combine equations, combine linear equation, and then finally we substitute values. Substitute variables, variable values. And so we figure out the solution of the system is going to be 6 comma negative 9. The end. In the worked example, only one equation needs to be rewritten to solve the linear combinations method. Why? Well, if we understand one of the variables, let's write it out. It's 4x plus y. Equals, well, we don't care what it's equal, but it's equal to 15. Now, we don't care exactly It was 7x. We don't care exactly what it is. So we don't need to mess with both of them. We only need to transform one of the equations. This has a coefficient of, the x has a coefficient of 4. The number next to the x is 4. Well, can we multiply the 4 to equal 7? No. Can we multiply the 7 to equal 4? No. Well, yeah, but not nicely, so let's forget about it. 2y. Can we multiply the 2 to get 1? Well, yeah, 1/2, but then we have 1/2 of 7, and that's 3.5. Don't like that. But can we multiply the 1, this 1 right here, to equal 2? Yes. So we can mess around, we can transform this second equation right here because it has a coefficient of 1. The coefficient of 1 lets us multiply the number and get that number in return. By multiplying by -2 to both sides, let's actually type this. By multiplying the second equation, let's type it out. 4x plus 1, let's put 1y is equal to 15 by -2. Y's in either equation become additive inverses. So we get, in all actuality, we get 2y, we're going to get a 2y and a -2y, and when we add them together, 0. Now, there are certain situations, systems, where both equations need to be rewritten. So in that case, we have to figure out, okay, what's the other number? And see, okay, sometimes we just need to multiply by the other number. So we're going to get rid of, looking right here, it looks like we're going to get rid of this 6y right here. 6y and -6y. Well, we have 2y and 3y. Okay, well, 2 times 3, 2 times what equals 3? Nothing. 3 times what equals 2? Nothing. But we can multiply one of these by the opposite coefficient. So I can multiply this 2y by 3. And I can multiply this 3y by 2. And that will give me 6y and 6y. Oh, wait a second. They have to be additive inverses. So one of them has to be negative. And so that's why we're going to multiply by -2. And this becomes -6. But remember, it's an equation. It's in an equation. So we have to multiply that 3 to everything in the equation. And we have to multiply -2 to everything in the equation. So it says, determine the solution for the linear system shown in the second worked example. Okay, well, if we add these together, we get 2x plus 0 is equal to 1. So 2x equals 1. So x is equal to, divide by 2 on both sides, 1/2. Take that number and plug it back into the equation. So 4 times 1/2 plus 2y equals 3. Half of 4 is 2. 2 plus 2y is equal to 3. So if we subtract by 2 on both sides, we'll slowly solve for y. 2y is equal to 1. Hey, this looks like that 2x equals 1. And we're going to see that y is equal to 1/2. So the solution for this equation is going to be 1/2, 1/2. How could you solve the system by creating x values that are additive inverses? Well, we understand that one was 4x and one's 5x. So we can multiply by the opposite coefficient. So we can multiply by -4 and multiply by 5. And that would give us 20x and -20x. So to create x values that are additive inverses, we can multiply by the other coefficient of the x value. So for example, the 4x, we're going to multiply it by 5 because the 5 is the other coefficient's value. And we're going to multiply it by 4 to the 5x. But one of them needs to be negative. Otherwise, we're going to have 20x plus 20x, and that's not 0, that's 40x. All right, let's continue. Describe the first step needed to solve each system using the linear combinations method. All right. 5x plus 2y is equal to 10. 3x plus 2y is equal to 6. All right. Well, to get the additive inverse, we would multiply one of the equations by -1. Because if we do that, then we would get a -2y plus 2y. And that will get rid of y, the variable y. All right. 3 times what equals 2y? Nothing. 2 times what equals 3y? Nothing. 5 times what equals x? 1x? Nothing. 1 times what equals 5x? Wait a second here. For this one, I would multiply 1x by what to equal 5x? 5. But I'm going to multiply it by, I would multiply to get the additive inverse. I wouldn't multiply by 5. I'd be multiplying by -5 to both sides. So go ahead and write that down right here. What would we do? Now I'm going to write it, and I want you to write the sentence. Now this one's going to be a little bit different because it has multiple different things. We have 4x and 3x, 3y and 2y. Now there's 2 different ways we could solve this. We could either get rid of the y's or get rid of the x's. If we want to get rid of the y's, then we'd be multiplying by the opposite coefficients. We can multiply by 2 to the top equation, and we can multiply the bottom equation by not 3, but -3. So times the top one by 2, and times the bottom equation by -3. And that will create an additive inverse of the y's, specifically 6y. Go ahead and write that sentence out right here while I write out the equation of what it would look like. Now you don't need to write this. I'm just showing you what it would look like. 8x, -3 times that, -9x. And so if we add these together, the y's would cancel out. Now I guess we should go back and write this out. The y would be the additive inverse. All right, let's pause for a second. All right, guys, I'm going to do one of these, and then I'm going to ask you to finish this off for the weekend, okay? For extra credit. Analyze each system. How would you rewrite the system to solve for one variable? Explain your reasoning. So pretty much, do we need to multiply by anything? Do we need to leave it alone? What do we have to do? 1/2 x minus 5y is equal to negative 45. Negative 1/2 x plus 10y is equal to negative 20. Well, nothing. Nothing. I wouldn't have to multiply. I wouldn't have to rewrite the system, because if I add it, these cancel out, and I'm left with 5y is equal to negative 65. And then I could solve for y and then solve for x. So I don't have to multiply, subtract, add, whatever to get this. Let's do one more. Now 4x plus 3y is equal to 24. 3x plus y is equal to negative 2. Now I have a coefficient of 1. So I times this by negative what? Well, it's 3y, so I times it by negative 3. After I get that, then I would get my reasoning. So I would write down, I would multiply the second equation by negative 3 because I would figure out the additive inverse of 3y is negative 3y, and y times negative 3y is negative 3y. All right, guys. Good luck on your weekend work. Bye.